All right, gearing up for your GCSEs? Then you know that energy changes and reactions is a huge topic. So in this explainer, we're going to break it all down into a super simple exam-ready survival kit. Let's get right into it.
So let's just kick things off with a question. What is the number one, the absolute biggest mistake that students make that costs them easy marks on this topic? It's actually way more common than you'd think, but trust me, by the end of this, you'll know exactly how to dodge it.
You know, the secret to absolutely smashing this entire topic, it all boils down to one core idea. It's not really about heat, it's not about temperature, it's all about the chemical bonds holding everything together. Once you get this one thing, I promise everything else just clicks into place.
This right here, this is the golden rule. Seriously, memorize it, understand it, live by it for your exam. Every single thing we're about to talk about is built on this one simple sentence. You have to put energy in to break bonds, and you get energy out when new bonds are made. That's it. Think of every single chemical reaction as a simple two-act play. Act 1, you have to spend a bit of energy to snap all the old bonds in the reactants. That's your energy investment. Act 2, as the new, stronger bonds form in the products, a bunch of energy gets released. That's your payoff. It always happens in that order.
So why are we hammering this point so hard? Well, because clearly explaining this two-step process, connecting the energy changes directly to the breaking and forming of bonds, is exactly what examiners are looking for. Getting this right can easily grab you 3, maybe even 4 marks on just one question. Okay, so if every reaction has these two steps, what makes them different? Well, it just depends on which step is bigger. Did you get more energy out than you had to put in? Or did it cost more energy than you got back? This simple comparison gives us our two main types of reactions, exothermic and endothermic.
Now here's a super simple trick to keep these straight, and it works every time. For exothermic, just think of the energy exiting the reaction. It's leaving. For endothermic, think of the energy having to go into the reaction. Easy as that.
This slide lays it all out perfectly. Think of it like an energy budget. In an exothermic reaction, you get a bigger payoff from forming new bonds than what you spent breaking the old ones. That leftover energy exits, and that's what makes the surroundings feel warmer. For endothermic, it's the opposite. The cost of breaking the bonds is greater than the payoff. So the reaction has to pull in some extra energy from the surroundings to make up the difference, and that's why things feel cooler. So we've been talking about these energy changes, which can feel a little abstract, right? But how can we actually see them? Well, that's where energy profile diagrams come in. They're basically simple graphs that give us a visual map of the energy journey a reaction takes from start to finish. Let's just do a quick tour of the diagram so you know what you're looking at. The up and down y-axis is all about the amount of energy. The left to right x-axis is just the reaction moving along. You've got your starting energy level for the reactants, your finishing level for the products, and that little hump in the middle, that's the activation energy. Just a little energy boost needed to get the whole thing going. And boom, this is what an exothermic reaction looks like. It's all downhill. See how the reactant started a higher energy level than the products? That's because overall, energy has been released. It has exited. The reaction has given its extra energy to the surroundings, so the products end up in a lower, more stable energy state.
Now, the endothermic diagram shows the complete opposite story. This one is an uphill journey. The reactants start at a lower energy level and actually finish up higher. And why is that? Well, because the reaction had to take energy in from its surroundings to even happen. You can literally see that the products are now storing that extra energy.
All right, we've covered the core ideas. Now for the most important part. How do we translate all this knowledge into a perfect, mark-winning exam answer? This right here is your practical toolkit. Okay, this is so important. You have to use the right language. Examiners want to see phrases like energy transferred, and they absolutely need to see you talk about bond breaking and bond forming. And remember that number one mistake we talked about at the start? It's right there in the don't column. Just saying it gets hotter is not a good enough answer. You have to explain why it gets hotter by talking about the energy released when new bonds are formed. Okay, final self-check just to lock all this in your brain. Quick questions for yourself. Does breaking a bond require or release energy? What about making a new bond? And which type of reaction, exo or endo, releases more energy than it takes in? If you can answer those confidently, you are totally in control of this topic. So there you have it. You've now got the complete toolkit for your exam. But here's a final thought to take with you. This isn't just stuff for the classroom.
From a campfire to a cold pack you put on an injury, these reactions are happening all around us, all the time. Now that you know the rules, where else can you spot them in action?